Welcome to today's tutorial. In today's tutorial, we are going to continue on set theory. However, today we are going to look at power sets. Fast forward, we look at operations on sets, under which we look at intersection, union, complement, and difference of sets. And lastly, we look at some important theorems under set theory. Power sets. Assuming you have a set A given as A, B, C, how many subsets can you form from the set A? Let's try to list some of them. So I can form a set with only the first element. I can also form a set with the second element B, and same with C. Now I can combine A and B together to form another set, and I can also put A and C to form another set. And likewise, I can do B and C as another set. Another set that I can also form again is the trivial set, and that is the set itself, A, B, C. Now, is this all that I could do? The last one and the most special one is the set formed by the empty set. This is also a subset from the set A. In our earlier tutorials, we talked about the empty set being a subset of every set. So if you have any set at all in consideration, the empty set is a member of that particular set. So when we count, we have 1, 2, 3, 4, 5, 6, 7, and 8 subsets from this set A. When we put these sets together, it becomes set of sets. So when I put it together into one set, I have A, B, C. When I put them together this way, they form another set, and that set is called the power set of A. And it is denoted by good. So the power set of A has all these elements in it. So for any arbitrary set given, you can form a certain number of subsets from it. And in this case, from A, we have formed this. So by definition, the power set of a set A given us is equal to X, such that X is a subset of A. This is the definition. However, an important note to take is that the empty set is a subset of every set. Okay? And also, every set is a subset of itself. These are very important concepts you need to know at every point in time. Okay. Now, in the example we just solved, we had A containing 3 items. However, the power set of A ended up giving us 8 items. How are the orders of these two sets related? So, the order of the power set of A is given by 2 to the power the order of A. In some books, you would see if the order of A is n, then the order of the power set of A is going to be 2 to the power n. So that is it. Let's take one example more. Assuming I have a set S to be equal to A2, what is the power set of S? So we take them. The first set or subset we can form from S is the element containing just A. And the second one is the element containing just 2. Now we put A2 to form another subset. And the last one is going to be the empty set. These two guys are trivial. In every power set, they need to appear. The set itself must appear in the power set. And the empty set must also appear in the power set. So the power set becomes A2, A2, and phi. Right, so that is it. And the order becomes 4. And that is technically 2 to the power 2. We know from our earlier discussions that the order for the power set of P is going to be 2 to the power the order for P. And that in this case is going to be 2 to the power 8. So this is the answer for this particular question. The next thing we are going to look at in this tutorial is operations on sets. What do we mean by operations on sets? Let's take some arbitrary sets A to be equal to A, B, C, and another set B to be equal to 1, 2, 3. We want to find the union of these two sets, and that is denoted by A union B. This is simply putting together all the elements in A and B. And in the case where there is repetition, you ignore the repeated elements. You write just one of them. So in this case, we have A, B, C from the set A. And we add that in B, and that is 1, 2, 3. This is the union of A and B in this situation. Let's take another example. Let's say we have a set S equal to M, N, O, P, K, S, and another set R to be equal to N, P, S, 1, 2, 4. The union of these two sets, S union R, is given by, we put together the elements in the two sets. So I'll first write all the elements in the set S. So M, N, O, P, K, S. And I add all the elements in set R. However, those that repeat themselves we do not write them again. So I could see n here and it is already in the set. And I could also see p, which has already appeared here. Likewise, I could see s, which is already. So all I do is to write the remaining 1, 2, 4. And that becomes the union of the sets S and R in this situation. All right. Let's take an example. What if we have 3 sets or more? Assuming I have a set X to be equal to A, B, and another set Y to be equal to 1, 2, 3, and Z say 1, 2, M, Q. When I want to take the union of these three, and that is going to be X union Y union Z, what is this set going to be? You may pause the video and try your hands on it. Fine. So it is the same approach. We only write the elements in them, avoiding the repeated ones. So in X we have A, B. Now in Y we have 1, 2, 3. In Z, however, we have 1 again and 2, which are already in the union set we are writing. So the only thing we do is to write M and Q, which has not already appeared in the set. So this becomes the union of these three sets. On that note, it follows to say that if you have set A1 union A2 union, and it continues up to the union of AN, this can be denoted as a bigger union with I starting from 1 to N of AI. This notation tells you that you are taking the union of N sets starting from 1 to N of AI. So all you do is to list the elements of each of the sets and take the union of all of them. Okay, so you take note of this notation. The next concept we are going to look at is the intersection. Let's say we have the sets, a set A equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 to 10, and another set B to be equal to 2, 4, 6, 8, 10. The intersection of A and B is denoted by A intersection B, and that is simply elements in A and at the same time in B. So when we look at the two sets, I see 2 here, we see 2 here. There is 4, there is 4. There is 6, there is 6. There is 8, there is 8. There is 10, and there is 10. So the intersection becomes 2, 4, 6, 8, 10. Obviously, we could say this is equal to the set B, and that is because B is a subset of A. Otherwise, we wouldn't have gotten this same answer. Let's take, for example, a set M to be equal to 2, 3, 5, 7, 11. And another set Jane to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we want to find the intersection of M and Jane, this would be equal to, we list elements in the two sets. So we have 2 here, 2 here. We have 3 and we have 3. And as well, we have 5, we have 5. We have 7 and we have 7. So the intersection set is going to be 2, 3, 5, 7. Okay, this becomes our answer. The last example I want us to look at is, let's take a set X to be equal to M, N, O, and another set Y to be equal to -2, 3, and 4. Finally, Z to be equal to alpha, beta, and gamma. What is the intersection of X and Y and Z? When we look through, we could see that there is no common element between these three sets. So that means the intersection set is the empty set. So how do we write the empty set? This is equal to just this, or someone may write this. Please take notes and make sure you do not write the answer as this. This is wrong. Remember, we discussed earlier that this is a singleton set containing phi as its only element. So this is not the empty set. This is a set containing the empty set. So you take note. Let's take one more example. Assuming I have my sets Q containing 1, 2, 3, 4 to 5. And I have another set R containing A, 2, 3, B, and C. Another set T containing M, N, 3, 4, P. What would be the intersection of Q and R and T? Let's look at the common elements through them. I could see 3 in each of the sets, and that is the only element that runs through. Even though we have 2 in Q and 2 in R, there is no 2 in T, and so 2 does not qualify to be in the intersecting set. Likewise, we have 4 in Q and 4 in T. However, there is no 4 in R, so it does not qualify to be in the set. So the intersection contains only 3, and that is a singleton set. It follows to say that we can have intersection of multiple sets. Say A1 intersection A2 intersection up onto AN, and this can be denoted by a bigger intersection of AI with I starting from 1 to N. This notation means you are taking intersection of N sets starting from A1 to AN.